All right, happy Friday, y'all. Today is May 1st. If you would please write in your table of contents that today our goal is to explore the key features of quadratic functions. And you're going to add pages 85 and 86 to your binder. But first, I would like to go over page 84 from yesterday. So I've asked that your sub go ahead and hand back page 84. And I'll flip over there in just a moment. Okay, this was page 84 from yesterday, where we talked about how to solve equations by factoring whenever it wasn't in standard form or equal to 0. And I asked you to work on the back. So I'd like to go through these problems together. Number 6, 3x squared plus 2 equals 5x. Well, I don't want it to equal that 5x, so I'm going to cancel out the 5x by subtracting 5x from both sides. And on the left side, because negative 5x doesn't have anywhere to take away from, I'm just going to squeeze it in the middle and write this as 3x squared minus 5x plus 2 equals 0. Then, now that I've got it in standard form equal to 0, it's time to factor it. We'll use the slide and divide method to rewrite that as x squared minus 5x plus 6 equals 0. I'm finally ready to find the factors that multiply to positive 6 and add to negative 5. Now, since it multiplies to a positive, the signs match. Since they match and add to a negative, they are both negative. So I know I'm looking for two negative numbers whose product is 6 and whose sum is negative 5. And those numbers are just going to be negative 2 and negative 3. So negative 2 times negative 3 is 6. Negative 2 plus negative 3 is negative 5. Now, a factor of x minus 2 would give you a solution of x equals 2. And a factor of x minus 3 will give you a solution of x equals 3. But I do need to divide both of those numbers by 3, because that's the number I used for the slide and divide method to get rid of that leading coefficient. 2/3 doesn't simplify, doesn't divide evenly. You can just leave it as 2/3, or you can write 0.6 repeating. 3/3 is just 1. Your answers are 1 and 2/3. For number 7, I've got 5x squared plus 15x plus 1 equals x plus 4. I'm going to cancel out the x by subtracting x from 15x. 15x minus x is 14x. I'm also going to cancel out that plus 4 by subtracting 4 from 1. 1 minus 4 is negative 3. So this boils down to 5x squared plus 14x plus 3 equals 0. Now that I've got it in standard form equal to 0, I can go ahead and start the slide and divide method, pull that 5 to the back and rewrite it as x squared plus 14x minus 15 equals 0. And now I'm ready to find the factors of negative 15 that add to 14. Because it multiplies to a negative, the signs are going to be a mix of one positive and one negative factor. The only numbers that could possibly multiply to negative 15 and add to 14 are positive 15 and negative 1. Which means you've got a factor of, because you've got a factor of x plus 15, you've got a solution of x equals negative 15. And because you've got a factor of x minus 1, you'll have a solution of x equals 1. But then we'll divide both of these by 5. Negative 15 divided by 5 is just negative 3. 1 divided by 5 is just 1/5, or 0.2. Next up, 15x squared minus 10x plus 4 equals 6x. I'm going to cancel out that 6x by subtracting 6x from both sides, and I'll take that away from the 10x. That'll leave me with 15x squared minus 16x plus 4 equals 0. There's no GCF, it's in standard form equal to 0, so that means I'm going to use the slide and divide method to factor this. I'm going to rewrite this as x squared minus 16x. 15 times negative 4 is, 15 times 4 is 60. I'm looking for factors of positive 60 that add to negative 16. Because they multiply to a positive, the signs are going to match. Because they match and add to a negative, they're both negative. So I know I'm looking for two negative factors. The numbers that multiply to 60 and add to negative 16 are negative 6 and negative 10. A factor of x minus 6 gives you a solution of x equals 6. A factor of x minus 10 gives you a solution of x equals 10. And then we will divide both of these by 15. 6 over 15 reduces down to 2/5, or 0.4. 10 over 15 reduces down to 2/3, or 0.6 repeating. Please don't be afraid to ask your sub to pause the video if you need more time or need time to get caught up. I'll leave this up here for just a moment. Okay, let's take a look at number 9 and 10. 9 and 10 involve this word problem. Sean and Johnny are experimenting with different builds of model rockets. They each built a rocket and launched it from various heights. They compare the heights in feet of each rocket compared to the time, t, in seconds since the rocket was launched. The height of Sean's rocket can be calculated using s of t equals negative 4t squared plus 8t plus 30. The height of Johnny's rocket can be calculated using j of t equals negative 2t squared plus 3t plus 23. Number 9 says, after how many seconds do Sean and Johnny's rockets cross paths? If their rockets cross paths, that means they're at the same place at the same time, specifically the same height. So all I'm going to do here is I'm going to take this formula and set them equal to each other. So, looking at Johnny's rocket, negative 2t squared plus 3t plus 23. And then Sean's rocket, negative 4t squared plus 8t plus 30. And I am going to set those two functions equal to each other. Now, it doesn't matter which one you put first, so I could have had Sean's over here and Johnny's over there. It really doesn't matter. I do need to make sure that this equation has a quadratic function equal to 0, meaning I need to get all of this stuff canceled out. So, to cancel out the negative 4t squared, I'm going to add 4t squared to both sides. To cancel out the positive 8t, I'm going to subtract 8t from both sides. And to cancel out the positive 30, I'm going to subtract 30 from both sides. Negative 2t squared plus 4t squared is positive 2t squared. 3t minus 8t is negative 5t. And 23 minus 30 is negative 7. Equals 0. Now, I do want to say, if I had canceled out all of this and had everything moved over to the other side, I would have ended up with a negative 2t squared, a positive 5t, and a positive 7. And at that point, you can just divide everything by negative 1 so that you don't have that negative up front. That would just end up with 2t squared, negative 5t, and negative 7. So from here, it's in standard form, it's equal to 0, there's no greatest common factor, so I'm going to start the slide and divide process and multiply 2 times negative 7 to rewrite this as t squared minus 5t minus 14 equals 0. I'm finally ready to find the factors. I'm looking for factors of negative 14 that add to negative 5. Since it multiplies to a negative, the signs are mixed. The only numbers that multiply to negative 14 and add to negative 5 are positive 2 and negative 7. So, a factor of x plus 2 gives me a solution of t equals negative 2, and a factor of t minus 7 gives me a solution of t equals positive 7. Finally, divide both of these by 2, because that's the number that we canceled out using the slide and divide method. Negative 2 over 2 is just negative 1. 7 over 2 is just 7 over 2, or 3.5. However, this t stands for a time. Well, the rocket can't be in the air for negative 1 seconds, but it can be in the air for 3.5 seconds. So the correct answer is really just 3.5. Which leads me to question 10. Question 10 says, how high in the air are Sean and Johnny's rockets when they cross paths? Well, this is a time, and both of these formulas give us a height based on the time, and this is the specific time where they cross paths. So all I need to do is take this number, 3.5, and plug it into either Sean or Johnny. It doesn't matter which one. Both of them are going to give me the same answer because this is the value that makes these things equal each other. So just pick one and go with it. I'm going to use Sean, and I'm going to take Sean's formula, S of t equals negative 4t squared plus 8t plus 30, and I'm going to plug in 3.5. And then solve, really not solve for anything, just evaluate the function. Now, I would not recommend doing this by hand, 3.5 squared, and then 4 times that, and 8 times that, and then add 30. Let's not do that. Throw it in your calculator, type it in all at once. The answer is 9. That just means after 3.5 seconds, both rockets are 9 feet in the air. Again, you could plug 3.5 into Johnny's rocket, and you would still get 9 feet. So I'll give you a second to get caught up on number 9. One thing I will say, on a test question like this, what I would really recommend doing, because this question would undoubtedly have Desmos available to you, I would recommend going to Desmos and typing this function in, and you would get something that looks sort of like that. And then type in Johnny's function, and you would get something that looks more like that. Well, it actually look a little bit more like that. Where they cross will be the ordered pair 3.5, 9. That point answers both questions for you, that after 3.5 seconds, both rockets are 9 feet in the air. Okay, please go ahead and put page 84 in your binder. And then I'd like for you to take a look at page 85. So if you haven't already, please grab page 85. Those papers are in the folder that I left for your sub. So if your sub hasn't already, please ask for page 85. So we want to talk about the key features of quadratic functions. Now, quadratic functions are called parabolas. The specific shape that they make is called a parabola, parabola. So what's the big deal with factoring quadratics? The factors of quadratics are closely related to several key features of their graphs. So I want to explore the function f of x equals x squared plus 2x minus 3 and graph the function. Now, anytime we want to graph a function, a really easy way to get that is to just take the function and make a table out of it. Now, if you wanted to do this by hand, you would have to take every single one of these numbers and plug it in for x. Then take -3 and plug it in for the x. And then take -2 and plug it in for the x. And that would take forever. So another thing you can do is open up Desmos or your handheld calculator and let your handheld calculator or Desmos do the work for you. I'm going to let Desmos do the work for me. So, put it on bold mode. I'm going to type in y equals x squared plus 2x minus 3. Is that what that was? Yep. Then, to make Desmos do the work for me, if you click this little gear icon that says Edit List, so I click this little gear icon right here, a couple of options pop up. The option I'm most interested in is right here, Create Table. That created a table for the function I typed in. Now I can fill in some values. The table on your paper goes from -4 to 2. So I can just hit enter, change that to -4, -3, and -2. And now I have all of the points. It did all of the work for me. So my y values are 5, 0, -3, -4, -3, 0, 5. So 5, 0, -3, -4, -3, 0, 5. You may have noticed some repetition there, and there's a really important point involving the repetition. The fact that it goes from 5 to 0, and then from 0 to 5. And it goes from 0 to -3, and then from -3 back to 0. And then -3 to -4, and -4 back up to -3. You'll see that visually whenever we start plotting these points. So -4, 5 is back 4 and up 5, so right here. -3, 0 is left 3 and just stay on the x-axis. -2, -3. -1, -4. 0, -3. 1, 0. And 2, 5. These points create a U-shaped graph. So whenever I'm start trending down towards that bottom point, it's going to be curved on the bottom. It doesn't make a V shape. It makes a U shape. And that is the shape of all quadratic graphs. Now, all quadratic graphs are either going to look like this or that. This one looks like this, but that U shape is called a parabola. So, next little part of this exploration before we get to our first key concept says, rewrite the function in its factored form. Well, let me go ahead and factor this guy. Factors of -3 that add to +2 would just be x plus 3 and x minus 1. And that's it. So I want you to compare the factors to the table to the graph. The first key concept says that the factors of a quadratic expression are the opposite of the x-intercepts of the function's graphs, also known as the zeros or roots. This can be found by setting each factor equal to 0. which is why it's called zeros. So I have a factor of x plus 3. The graph crosses the x-axis at -3. I have a factor of x minus 1. The graph crosses the x-axis at +1. I also want to point out that yesterday, and at the top of our class today, we already knew that if you have a factor of x plus 3, you have a solution of x equals -3. And if you have a factor of x minus 1, you have a solution of x equals 1. So this factor corresponds with the root of -3, which is why we also see the ordered pair -3, 0. The factor x minus 1 corresponds with the solution of x equals 1, which is why I see it crossing the x-axis at 1, and why the table has the ordered pair 1, 0. All of those are connected. Next up, I want to fill in the table of values and sketch the graph for x squared minus 6x plus 8. I'm going to let Desmos do all that work for me. So y equals x squared minus 6x plus 8. I'm going to click Edit List and click to create a table. And then the paper wants us to go from 0 to 6. And the reason it goes from 0 to 6 is because if you can see, like -1, 15 is not able to be plotted. But on the paper, you can plot all the y values that I see here. So I see 8, 3, 0, -1, 0, 3, 8. Again, I see that repetition. 8 down to 3, 3 up to 8. 3 down to 0, 0 up to 3. 0 down to 1, and then back up to 0. Let's go ahead and plot those points. I've got the ordered pair 0, 8, 1, 3, 2, 0, 3, -1, 4, 0, 5, 3, and 6, 8. It is okay if your parabola does not look perfect. They are difficult to draw by hand. So just do your best to create that smooth U-shaped graph. Oops. Okay. Let's factor this guy as well. The factors of 8 that add to -6 would be x minus 2 and x minus 4, which gives me solutions of x equals 2 and x equals 4. Again, not too much of a surprise, a factor of x minus 2, I see it crossing the x-axis at 2, and I see the ordered pair 2, 0, which is why I have the answer x equals 2. The other factor, x minus 4, I see it crossing the x-axis at 4. I see it with the ordered pair 4, 0, so the other solution is 4. But there's something else that's important about this. The numbers that we see repeating, 8 to 3, 3 to 8, 3 to 0, 0 to 3, 0 to -1, -1 to 0. They all repeat between or from -3. The pattern we see going this way is the same as the pattern we see going this way. That number 3 is a very important number for quadratic functions. So, filling in some of these blanks, the roots of a quadratic function are e, q, u, I, d, I, s, t, a, n, t. That word is pronounced equidistant. So, e, q, u, I, d, I, s, t, a, n, t. Equidistant just means equal distance from the parabola's axis of symmetry. An axis of symmetry is the vertical line across which a parabola is a mirror image of itself. Well, if I look at the graph, I see that the graph is sort of symmetric along this line that I'm dotting in orange. Everything to the left is the same as everything to the right. So this point is 2 steps to the left. There's another point 2 steps to the right. So this is your mirror image. Everything on the left happens the exact same way as everything on the right. That's important because in order to find the axis of symmetry, which you will have to do, you can just find it by averaging the roots. So, if I want to find the axis of symmetry, AOS, I'm going to take 2 and 4 and add them together and divide by 2. So, one of my roots was 2, the other root was 4, 2 plus 4 is 6, and 6 divided by 2 is 3. Your axis of symmetry is x equals 3. If you ever ask for the axis of symmetry, it'll always be a little x equals number equation like that. And it's just the number that it goes through on the x-axis. 3 is in the dead center between 2 and 4. So 3 is the axis of symmetry. Give you a second to get caught up. Okay, let's flip over to the back. On the back, I want to talk about 4 important key features of parabolas. First up, we've got the y-intercept. The y-intercept is just the y-coordinate where the function crosses the y-axis. So, in this example, this point right here is your y-intercept. That point is the ordered pair 0, 3, or just y equals 3. The x-intercept, really I should have said x-intercepts because you can have more than one. These are the x-coordinates where the function crosses the x-axis. For this example, I see an x-intercept here and another one over there. This x-intercept is the ordered pair -3, 0, or just x equals -3. This x-intercept is the ordered pair 1, 0, or just x equals 1. The axis of symmetry is a vertical line across which the parabola is a mirror image of itself. Well, the parabola sort of split down the middle right here. So that is your axis of symmetry. Here, your axis of symmetry is x equals 1 because it goes through 1 on the x-axis. Your vertex is the highest or lowest point on the parabola where it turns. For this example, the vertex is this point right here at the tip top of the parabola. That ordered pair is the ordered pair -3, -1. One thing to note is that the vertex and the axis of symmetry are always related. The axis of symmetry will always go through the function's vertex. And if I look back at the third example, the vertex of that is 1, -4. The x-coordinate of your vertex is the axis of symmetry. So let's see if we can identify these key features. The y-intercept is that point way up here, where it crosses the y-axis at 5. You can just write y = 5. You could have put the ordered pair 0, 5, but it doesn't matter. The x-intercepts, I see 2 of them. I see one there and one there. This x-intercept is at the ordered pair -5, 0, so just x = -5. This x-intercept is at the ordered pair -1, 0, so x = -1. Write that a little bit clearer. It's -5 and -1. I honestly feel like the vertex is easier to find first. The vertex is this low point way down here. And that one you always have to write as an ordered pair, and it is the ordered pair -3, -4. The reason I find it so much easier to find the vertex first is once you found the vertex, you found the axis of symmetry. The axis of symmetry is just x = -3. This answer will always be this number. And that's all there is to it. You may be asked if the vertex is a minimum or maximum. This one is a minimum because the vertex is the lowest point on the graph. Okay. This vertex is the lowest point. There's nothing further down than that point. You may also be asked if the parabola opens up or opens down. In this example, the parabola opens up, because both ends of the graph are pointing up. It'll open down if it looks like that, and if it looks like that, you would have a maximum. So these two answers are always related, and these two answers are always related. So finally, you may be asked to find the vertex coordinates for a quadratic equation. It's not difficult, but there is a healthy bit of work that we've got to do. So let's try finding the vertex of f of x = x squared plus 10x plus 21. Step 1, we're going to factor it. So let me go ahead and write this over here. We're looking for factors of 21 that add to 10. Numbers that would multiply to 21 and add to 10 are 3 and 7. So I'll go ahead and factor this and write x plus 3 and x plus 7. That's step 1. Step 2, determine the roots of the function by setting each factor equal to 0. However, since we've got simple binomial factors, all we end up doing is flipping the signs. That means our roots are x = -3 and x = -7. And that's step 2. Step 3, find the average of the roots. To do this, add the roots together and then divide by 2. So if I take -3 and -7 and I add them together and divide by 2, well, -3 plus -7 is -10. Half of -10 is -5. That number is the x value of the vertex as well as the axis of symmetry. So I know my final answer is going to start with -5 comma something. Just need to figure out what the y-coordinate is. That's step 3. Step 4, we're almost done. Finally, plug in the answer you got from step 3 into the function. So we're going to evaluate f of -5. Our answer is going to be our corresponding y value. So we have f of x equals x squared plus 10x plus 21. Well, I'm going to take this -5 and plug it in down here. Then you can throw that in your calculator or do it by hand. -5 squared is 25. (10 times -5 is -50. 25 minus 50 is -25. -25 plus 21 is -4. That's your y-coordinate. Your vertex is the ordered pair -5, -4. And that's step 4. So to recap all of that, factor the expression, switch the signs, find the average of those two numbers, so -3 and -7 average to -5, then plug that number back into the function. Follow the order of operations or use your calculator. The answer you got from step 3 is the x-coordinate. The answer you got from step 4 is the y-coordinate. One thing to keep in mind, this number, -5, is your axis of symmetry, which is the number in the dead center of -5 and -7. -3 and -7. -5 is the midpoint from -3 to -7. Okay, I've got one more paper that I want us to look at. So let's look at page 86. This has some EOC style questions that we want to work through. So let's talk about some of these together. Number 1, a quadratic function f of x has zeros of x equals -3 and x equals 12. Which equation gives f of x? This is asking us to kind of think backwards here. If we have a 0 of x equals -3, then we must have had a factor of x plus 3. We're going to switch the sign back to go to the parentheses. And then if we had a 0 of x equals 12, we must have had a factor of x minus 12. Well, once I've got those, I can just double distribute. So x times x is x squared. X times -12 is -12x. 3 times x is positive 3x. And 3 times -12 is -36. In the middle, we've got some like terms. -12 and positive 3 add to -9x. So your answer is x squared minus 9x minus 36, which is option B. Number 2, what are the zeros of the function f of x defined as f of x equals 2x squared minus 9x plus 7? Anytime it says what are the zeros, it's really just asking you to solve the equation. So all I'm going to do is set that equal to 0. Then, because there's no GCF and there's a number in front of the x squared, I'm going to start the slide and divide process. Rewrite that as x squared minus 9x plus 14 equals 0. Factors of 14 that add to negative 9 are negative 2 and negative 7. A factor of x minus 2 gives you a solution of x equals 2. A factor of x minus 7 gives you a solution of x equals 7. Because we started that slide and divide process, I'm going to divide both of those by 2, which gives me my final answer of x equals 1 and x equals 7 over 2, or 3.5. Positive 1 and positive 3.5 gives us option D. Now, if you had Desmos on this question on your EOC, honestly, all I'd say is type in that function and see where it crosses the x-axis. It crosses at 3.5 and at 1. Speaking of where it crosses the x-axis, that's how you're going to answer number 3. Which of the following gives the equation of this graph? Well, this graph is really closely defined based on where it crosses the x-axis. It crosses here and here. Now, one of these is a lot easier to see than the other. X equals 4. Now, if you had a solution, a 0, an x-intercept, a root of x equals 4, then you must have had the factor x minus 4. On the other hand, the graph crosses between 0 and negative 1. So that is negative 0.5. Now, every single time you have one that's a decimal value, change it to a fraction, because the function is written using, well, not really using fractions, but you need the fraction to get your final answer. Because if we have a solution of x equals negative 1/2, we must have had x plus 1/2 as a factor. Except, to write it in standard form, no one leaves it as a fraction, and they'll just pull that denominator up front. So this 2 swoops up front to rewrite that factor as 2x plus 1. So, since it crosses at positive 4, I'm looking for x minus 4. And since it crosses at negative 1/2, I'm looking for 2x plus 1. The only answer that could possibly be right is option B. Now, again, if you had Desmos, maybe your best bet is to throw all 4 of those options into Desmos and see which graph picture pops up looking exactly like the graph we had here. Number 4, the terminology scares a lot of people. What is the negative 0 of the function? Remember, a 0 is just the solution to the equation where this guy is equal to 0. So really, this is just asking for the negative answer. So, what I'm going to do here is set this equal to 0 and solve. 6, 5, and negative 4 don't have a common factor, so I'll start the slide and divide process. 6 times negative 4 is negative 24. Now I'm looking for factors of negative 24 that add to positive 5, excuse me. Those will be positive 8 and negative 3. Be careful, there's a trap answer here. A lot of people see that negative 3 and they circle B. B is not the correct answer. Because whenever you have factors of x plus 8, you've got a solution of x equals negative 8. And if you've got a factor of x plus 3, you have a solution of x equals positive 3. Don't forget to switch your signs. But guess what? A lot of people look at that negative 8 and think, oh, the answer is A. It's also not A, because we did the slide and divide method with that 6. So we need to divide both of our answers by 6. Negative 8 divided by 6 reduces down to negative 4/3, or negative 1.3 repeating. 3/6 reduces down to 1/2, or 0.5. We wanted the negative answer, so I'm going to ignore the 1/2 and go with negative 4/3. If you were working with Desmos, you could just type this guy in. You'll get a graph that looks something like this. Wherever it crosses on the negative side of the x-axis is your answer. Give you a second to get caught up. Okay, flip it over to the back. Number 5. A quadratic function is defined by the equation f of x equals 2x minus 5 times x plus 7. What is the equation of the axis of symmetry for the function's parabola? If you want to find the axis of symmetry, you need to find the zeros. To find the zeros, you need to set each of these factors equal to 0. 2x minus 5 and x plus 7, and set it equal to 0. Then I'm going to add 5 to both sides to get 2x equals 5, and then divide by 2 to get x equals 2.5. On the other one, I just need to subtract 7. Which gives me x equals negative 7. Now, neither of those is the answer. It's really nice that they didn't leave it as an answer choice, but because to find the axis of symmetry, we need to average these two numbers. Negative 7 and 2.5 added together, divide by 2. Well, negative 7 plus 2.5 is negative 4.5. Divided by 2 is negative 2.25. The correct answer there is C. On Desmos, you can just type this in exactly as it's typed in or written down here, 2x minus 5, x plus 7, both in parentheses side by side. You would get a picture of a graph that looks something like this. You just need to click on the vertex and see what the x-coordinate of that vertex is to find the axis of symmetry. The x-coordinate will be negative 2.25. Okay, number 6. A quadratic function has a factor of x minus 3. Its axis of symmetry is x equals negative 1. What is the other factor? I am going to draw a really long x-axis. I don't need much of a y-axis here. Now, it has a factor of x minus 3. That means its 0 or root or solution or x-intercept is x equals 3. So let me go ahead and go out to 3 and plot that point. Now, it says its axis of symmetry is negative 1. So let me go over here to negative 1, and I'll go ahead and draw a vertical line. So, however far to the right one of the zeros is, the other 0 is equally far to the left. So, since this is 4 steps to the right, I need to take another 4 steps to the left. So 1, 2, 3, 4. which puts me at -2, -3, -4, -5. And if I have a solution of x equals -5, then I must have had a factor of x plus 5. The correct answer is D. Okay, number 7. A gardener has a rectangular vegetable bed currently measuring 10 meters long by 5 meters wide. He plans to increase the size of his garden to be able to grow more crops. He wants to add the same amount of fencing to both the length and width of the garden, and he wants to triple the area of the garden. Write and solve a quadratic equation that can be used to determine the length in meters of the newly enlarged garden. So he's got a rectangular garden. I'm going to draw that here. That is 10 meters long by 5 meters wide. And I think it's important to note that 10 is the length and 5 is the width. Now, because it is a 10 by 5 garden, the area is 50 square meters. Now he is going to enlarge the garden so that it's triple the area. So let me draw a larger rectangle. And the only thing I know about it is it's going to be 150 square meters. But I don't know what the length is and what the width is. But I do know that I'm going to tack on the same amount to the width as I am to the length to make it that 150. So let me draw this diagram down here. I'm going to take my original rectangle and I am going to tack on a little bit to get 150. Now, this was already 5, but I'm adding something, but I don't know how much. Or nope, that wasn't 5, that was 10. This was 5, but I'm adding something, and I don't know how much, so I'm going to call it x. That means that 5 plus x times 10 plus x is going to have to equal 150. 5 plus x is the width after I've added however much I'm adding. 10 plus x is the length after I've added how much I'm adding. And the width times the length gives you the area. Well, I know the area should be 150 because I'm going to triple the area of the garden. The original garden was 10 by 5, so I triple 50 to get 150. To solve this one by hand is a lot of work. First off, I think it's easier if I have the x and the factor switched around. So I'm going to write this as x plus 5 times x plus 10 equals 150. And I'm going to have to double distribute that, set it equal to 0, refactor, and solve. So if I double distribute, x times x is x squared plus 10x plus 5x plus 50. Then I'll need to subtract 150 from both sides to get x squared plus 15x minus 100 equals 0. And then I can factor it to x plus 20 times x minus 5. Because 20 times negative 5 is negative 100, 20 minus 5 is 15. I factor of x plus 20 gives you a solution of negative 20. A factor of x minus 15, or x minus 5 gives you a solution of x equals 5. Now, I can't actually subtract 20 off of each of these dimensions. It wouldn't make a larger rectangle. It wouldn't make a rectangle at all. But I can add 5. So the only correct solution here is 5. So 10 plus 5 gives me 15. And 5 plus 5 gives me 10. So the new garden should be 10 by 15. The question was, what is the length? The original length was 10. The new length is 15. The correct answer is 15. One thing I want to caution you about here. All of these answer choices, the 5, that's how much you add. The 10, that's the new width. The 20, honestly, I don't know. The 20 is just a number. But these answer choices really try to trip you up. Also, this work that I did right here, not easy to do, not intuitive at all. As long as you can set this up, you can go into Desmos and find that 5 pretty easily. You still just have to know what to do with it afterwards. So if I go to Desmos, and I type in y equals 5 plus x, 10 plus x, and y equals 150. I'm going to have to zoom out quite a bit. If you hold down the shift key, you can scrunch in the y-axis. And I can see that those two graphs cross at negative 20 and at positive 150, or at positive 5. Well, that's these two answers that I got right here. So if you just set this up and say y equals this and y equals that, you can just see where they cross. And if you did this question a billion times in a row, whatever dimensions it gave you, it would always be that dimension plus x and the other dimension plus x. And it doesn't matter what order you write them in. Last one, this one's a decent bit easier. 3 functions f of x, g of x, and h of x are given. Identify any true statements below. So either f and g have the same axis of symmetry or f and h have the same axis of symmetry. And then maybe f and g both have a root of negative 2 or f and h both have a root of negative 2. Well, to answer that, it's going to be a lot easier to do that if we factor these. So let me jot this down. F of x. Its factors are x plus 2 and x plus 4. Because 2 times 4 is 8, and 2 plus 4 is 6. A factor of x plus 2 gives me a solution of negative 2. A factor of x plus 4 gives me a solution of negative 4. The axis of symmetry is just the number in the dead center of negative 2 and negative 4, which will be negative 3. Let's do the same thing for g of x. G of x, we're looking for factors of negative 4 that add to 0. That's one of those special cases that just factors to x plus 2 and x minus 2, which means you get a solution of negative 2 and positive 2. The axis of symmetry is the average of these two numbers. Well, the average of negative 2 and positive 2 is 0. Finally, h of x. We're looking for factors of negative 16 that add to positive 6. That would just be positive 8 and negative 2, which means you have a solution of negative 8 and positive 2. The axis of symmetry, negative 8 plus 2 is negative 6. Half of that is negative 3. So, evaluate these statements. Do f and g have the same axis of symmetry? Well, f has an axis of symmetry of negative 3. G has an axis of symmetry of 0. Option A is not correct. Do f and h? Well, f's axis of symmetry is negative 3 and so is h's, so option B is a true statement. Then, this says statements, so perhaps one or two of these others are also correct. Do F and G both have a root of -2? Well, F has -2, G has -2. And do F and H both have a root of -2? F has the -2, but H does not. So option D is not correct. Okay. I know that was a lot. Just wanted to get through as much as possible. Go ahead and put pages 84, 85, and 86 in your binders. If there's anything you need to take a second look at, you can go to Canvas now and you can look for the PDF scan of all of these pages. They're posted under today's date. So anything you need to check on, get caught up on, whatever, they're posted and linked directly under today's date. If you don't have anything that you need to get caught up on, you can work on any missing work you have for me, or you can work on any missing work you have for another class. Just make sure you're good, be polite to your substitute, and I hope you have a wonderful rest of your Friday. I'll see you on Monday. Y'all take care.